Now we are going to start matrices and determinants. So we are going to start with basic types of matrices. You should know. So first is identity amongst all identity matrix. Identity matrix is a matrix in which all the diagonal elements are 1 and except these are 0. Okay, all of these are 0. It can be anything, and the order is m cross m. Okay, these two are same, that is number of rows and number of columns are same. First is identity matrix. It is represented by I m cross m. Okay, then we have null matrix. Null matrix is a matrix in which all elements are 0. Okay, so example 0 0 0 0. This is also called O m cross m. M is the order, okay, of this matrix. M cross m is the order of this matrix. Now we have scalar matrix and we have square matrix. Square matrix, as you can just see that the order would be n cross n. Okay, so this is a square matrix, this is also square matrix. Okay, scalar matrix. Then we have diagonal matrix. Okay, so these are the main types of matrices. Now we'll move on to multiplication of matrices. So, okay, first property is that, first and most important, AB is not equals to BA in case of matrices. But in case of real numbers, x, y, let's say x and y are real numbers, so xy is equals to yx. But in here, AB is not equals to BA. Remember this is the most important property in case of multiplication of two matrices, two or more matrices. Similarly, ABC is not equals to any of the combination, BCA or CAB or ACB, any of the combination, okay, all the 6 combinations. Okay, and the second point is that if AB is equals to C, this implies that you can multiply A inverse A to the left hand side, AB, and A inverse to the right hand side, okay, C. Then you will get A inverse A as I, B is equals to A inverse C. Okay, so this is the multiplication property, that you can multiply with the inverse of a matrix lying at the first place, and so you can get the value of another matrix, the other matrix, and this is not equals to C inverse as discussed above. Okay, one other property is of transpose. We are multiplying two matrices A and B, so the transpose of the multiplication of A and B will be multiplication of B transpose and A transpose. Here order is important because this is not equals to A transpose B transpose, so you got to remember AB transpose is B transpose A transpose. Similarly with AB inverse, okay, T can be written as -1, T can be compared with -1. Here B inverse into A inverse, which is not equals to A inverse into B inverse. Okay, A inverse into B inverse. Fine. So we can have proof for this inequality. Okay, this equality proof, because it is important. So let's say AB inverse. We know that this is identity. Multiplying any matrix with its inverse, gives you identity matrix. Okay, and multiplying identity matrix with any matrix will give you the same matrix. Yeah. This is also an important property. And multiplying with null matrix will give you null matrix. Okay, so for this you have AB this side and AB inverse this side and is equals to I. Now, first of all, you will multiply this with A inverse on the left hand side to remove this A. So on the right hand side also you have to multiply this A inverse, okay, into I. So this 2 will give you I and you will remain AB inverse is equals to A inverse I. Now we will multiply with B inverse on both sides, okay. This will give you I, this will give you AB inverse is equals to B inverse, B inverse, A inverse, I can be neglected. So this is the thing, that AB inverse is equals to B inverse A inverse. Now I'll move on to another property of inverse and transpose. Okay, you remember this. A inverse is equals to A inverse A is equals to I. Okay, and A transpose is equals to I is only when there are orthogonal matrix. A is an orthogonal matrix. Okay, then only this property is satisfied. Otherwise, A transpose does not have any meaning. Okay, next property, transpose of transpose is A again and also inverse of inverse. Okay, so if you take transpose once and then you take once again the transpose of that matrix, then you will get the same matrix. Okay, now there are two types of matrices, symmetric and skew symmetric. Okay, so the main difference in between this is they deal with transposes. So A transpose is equals to A, then this is a symmetric matrix. If A transpose is equals to minus A, then this will be a skew symmetric matrix. Okay. If this is true, then you have to remember that all the diagonal elements of a skew symmetric matrix will be 0. Why is that? We'll prove this. Okay, let's see. If A transpose is equals to minus A, if this is A, B, C, D, E, F, G, H, I, fine, this is our A matrix. So A transpose will be A, B, C. These elements will be same. Okay, and these elements will get interchanged. So D, G, here will have H, here will have E, here will have F, and there I. Now, when A transpose is equals to minus I, this means A in this is equals to minus of A, because A transpose A, this A is equals to minus of A, that means this A. This implies 2A is equals to 0. This implies A is equals to 0. Similarly for B and C. Okay, similarly for B and C. So all the diagonal elements of a skew symmetric matrix are 0. Now, one more property we are going to deal with is about the minor. Okay, how to calculate the inverse of a matrix. Fine. So the property is minor of an element Aij, okay, of a matrix A, capital A, will be Mij, okay, minor, as it is a minor, so M. Now, this is determinant of the matrix that remains after deleting the ith row and jth column in A. Right? Now I will give you an example, and in that we'll calculate minors and all of this. So cofactors is our next definition. Cofactors represented by Cij. Similarly, like Mij, we have Cij. This is equals to minus 1 to the power I plus j Mij. Okay. Now, then we have adjoint of A, represented by Adja. This is calculated. This is the matrix, transpose of the matrix of cofactors. So transpose of, let's say you have 3 cross 3 matrix. So C11, C12, C13, C21, C22, C23, C31, C32, C33. The transpose of this means these will get interchanged, right? And diagonal elements will remain same. Now, from these three things, we get the inverse of the matrix. How? Let's focus on that. A adjoint of A is equals to adjoint of A. Remember this property, this important property, that A of adjoint A into adjoint A is equals to adjoint A into A, which was not true in case of A and B, because AB is not equals to BA. But adjoint is such matters that this property does not hold. Okay, we get a equal sign in here. So this is equals to mod A, and of course the multiplication with in, or you can say n cross n. Okay. Now, if mod A is equals to 0, this implies it's a singular matrix. This is also an important property because JEE has focused on many questions on this property. Okay, and otherwise, if this is not equals to 0, you have, of course, a non-singular matrix. Right. So we have these two properties. Now the formula for inverse, which I should write with a green pen. A inverse, important formula, 1 upon modulus of A, that is determinant of A matrix, into adjoint of A. Okay, this is an important formula which you should know before appearing to ITJ. Okay, so what is the proof behind this? Now, the adjoint A was a matrix with cofactors, transpose of cofactors, right? Now, if you have like A, B, C, D, E, F, G, H and I, this type of matrix, now for A element, you will calculate minor. Okay, let's say M11 because this is the 1-1 element. This A11 element because it's in first row and first column. Similarly, this is in B is in first row and second column. C is in first row and third column. So this will be A12. This will be A13. Fine. And this will be A21, A22, A23, A31, A32, A33. I explained it earlier. Because this is second row, this is third row, this is second column, third column. Okay, so that's why M11, because A11. Okay, first row, first column. In this, if you are calculating M11, then you will remove this row and this column. Then you will calculate the determinant of this matrix. What is the determinant of that matrix? EI minus HF. This is the M11. Similarly, M12 will be avoiding this and this. So you will get D, F, G and I. That will be DI minus GF. So cofactors will be C11 will be minus 1 to the power 1 plus 1. As you can see this formula. Cij is, you can see this formula, Cij is I minus 1 to the power I plus j Mij. Okay, so when we move down Cij, this will be equals to minus 1 to the power I plus j, that is 1 plus 1, m11, that is same as m11, so ei minus hf. But c12, you can see the change here, minus 1 to the power 1 plus 2, m12, this will be a negative sign, so minus 1 to the power 3 is negative minus 1, minus of that is minus of di plus gf. So simply you can calculate every Cij, and then you can take the matrix, you can make the matrix, and we'll take the transpose to get the adjoint of A, or C you can say. Okay, so adjoint of A you can calculate like this, and now the formula for inverse is this. So adjoint A, determinant of A you can calculate easily. If it's a 3 cross 3 matrix, then same process is applied. You take the A thing and you'll take ei minus hf, then minus b, this minus this, and then minus plus c, this minus this. Fine. So you will calculate that way the mod A, and you have your inverse. Fine. Now let's move on. We'll see some multiplication property which I have told you, but just to keep in mind, AB is equals to AC. This implies B is equals to C, not AB is equals to CA. This does not imply B is equals to C. You got to remember these properties because they are very important with respect to multiplication of matrices, and this has been many times, this has been asked in IIT JEE, that if A, C, B inverse K is equals to X, Y, A inverse and something like that, and you have to multiply with A inverse and you have to eliminate these two, then you'll get A inverse this side, then you multiply with C inverse. You just make this thing, like if you have to calculate K, then you'll just make them disappear by multiplying with their inverses and taking them this side. Okay, so this is the thing. Now we'll move on to the another property for matrices. There are a set of properties which we'll discuss one by one. First one is A transpose and inverse of that is equals to A inverse and transpose of that. Okay, so if you are taking transpose first or inverse first, that doesn't matter. You can take any one first and then apply the other one. Second property, adjoint of AB is equals to adjoint of B, adjoint of A. You can remember the two properties about transpose and inverse. Okay, first of all you write B inverse then A inverse. Here also B transpose then A transpose. Okay, so similarly for adjoint also. Okay, then third property about adjoint is the adjoint A modulus or determinant of adjoint A is mod A to the power n minus 1, where n is what? N is equals to order of A. Okay, n cross n, so n is the order. We always talk about n cross n or n cross m in case of matrices. Like if you calculate inverse, you can also only calculate the inverse of n cross n or m cross m matrix. Okay, order should be same, m cross m or n cross m. Okay, cross K anything, 1 cross 1, 2 cross 2, 3 cross 3, anything. Fourth property about this is adjoint A transpose of that is equals to adjoint of A transpose. This is also an important property. You can prove this by just taking one of the 3 cross 3 matrix or 2 cross 2 matrix, whatever you feel comfortable with. Okay, you can take any matrix and you can apply the adjoint property and transpose of that, and then A transpose and adjoint of that. Okay, you will see that these two comes to equal. So you have to remember this property. Adjoint of A, that will be equals to mod of A to the power n minus 2 into A. This is also an important property. We will not go with the proof of this because that will take time and we have to revise whole other things. So you can just remember this. Now another property is the discussion of evaluation of determinants. We'll discuss evaluation of determinants and how this is done. So I'll just tell one of the examples: A, B, C, D, E, F, G, H, I. Okay. Now, so first of all you will write the first element A11, that is A here. Then you will ignore this side and this side. You will just focus on this side, this box, this let's say green colored box. Okay, this box, you will concentrate on this and you will write EI minus HF. First of all we go this side, multiply both of them, then minus these two. Okay, then you will have minus B. You can see this is plus and then you have alternative signs. So for B you have minus B into, put the brackets on, then you will have which box? With this you will have this one and this one. Okay, let me mark it with red. This one and this one. So DI, first of all you will go this, multiply D and F, and then D and I, and then minus G and F. Fine. Then we'll move on to C. So alternative plus minus sign. So C into, what will be our color? What will be our box? This will be our box. Okay. Because except C, C's row and column, this will remain. So DH, this one, and then this one. GE, DH minus GE. So this is the value of determinant. Okay. Now, how to calculate area with determinant? So let's say you have a triangle and 3 points are given to you: x1, y1, x2, y2, and x3, y3. Now how to calculate the area shaded by this triangular region? For that you can do delta, that is area is equals to half of the determinant. Now x1, we will just write x1 y1 1, x2 y2 1, x3 y3 1, determinant of this matrix, and you'll just calculate it with this method. Okay, this is the method for calculation of determinant of a 3x3 matrix. Okay, and this is a 3x3 determinant. So this way you will calculate the area of matrix, and you can see there is, if you calculate determinant, then it will, of course area is a positive quantity, so you will take the mode of, if you are getting a negative term out of this box, then you will take a modulus of that thing, okay, to get the area positive. Moving on, we have number of equation topic. Okay, so if the system of equations has one or more solutions, then it is said to be consistent system of equations, otherwise it is inconsistent. So if system of equations has one or more solutions, okay, like when you have x square is equals to 0, then you have x square is equals to 1, then you have two solutions. Okay, so 1 and minus 1. So if system of equations has one or more solutions, then it is said to be consistent system of equations, and if it otherwise it is inconsistent. Okay, inconsistent system of equations. This is also an important point to note for this chapter. Now, matrix method to solve system of linear equations. First point, first of all, let Ax is equals to B, okay, and you have n linear equations. n unknowns, of course. Number of equations is always equals to number of unknowns to solve them properly. Now, first point is if mod A is equals to 0. Okay, this is our A matrix multiplied with X matrix to give a B matrix. So if determinant of A is equals to 0, this implies system is consistent and unique solution. Exists. Okay, unique solution will be X is equals to A inverse B. Now from our previous theory you can just calculate it. Okay, I am telling the proof in blue. AX is equals to B, multiply with A inverse both the sides. A inverse will multiply with on the left hand side of B, because we are multiplying A inverse on left hand side of A here, AX here. So A inverse A is I into X is X is equals to A inverse B. So you get X is equals to A inverse B as the solution. Now this is one part. Second part is if determinant of A is 0 plus adjoint A into B is not 0, then system is inconsistent. You got to remember this property. Proofs are very lengthy for these properties, so we are not going to do that. A third property, mod A is 0 and adjoint A into B is 0, then it will be consistent plus it will have infinite solutions. Infinite solutions as in X equals to 0, 1, 2, 3 and up to anything, or you can have repeating solutions. So infinite solutions will exist for this condition, and for this conditions you have inconsistent system. So you will calculate first of all this. First of all you will calculate mod A is equals to 0 or not. If that is the condition, then you will check for these. Okay, if it is not equals to 0 or it is equals to 0, then you will tell consistent and consistent system of equations. In the exam you will be given 3 or 2 or more equations, and then you have to assume A, X and B in that. A and B in that. X will be the variable, so you will just eliminate it. Whatever you get on the left hand side will be your A matrix. Whatever you get on the right hand side will be your B matrix. Okay, so that's how you can calculate adjoint A and B, and you can see that it is equals to 0, not equals to 0. Okay, so moving on to determinants.